stop sharing and then see everyone. Okay.
There's
Kylie, Joshua, Ketlo. Is that, sorry, did I say it right?
It's Catlow.
Catlow. Sorry, Catlow. Okay. I see Christina came in, Nathan, Hamza. Ryan. Sarah is.
a bit turned. Okay, she'll be here in a second. Okay. So we got 14. You and 2 of me is that gives us 11. So we still got a couple more to go. It's 6:30. Let's wait 1 more minute and then I'll just introduce you. Okay.
Sounds good. Yeah, that sounds good. 1, 2, yeah.
Somebody's pounding on the wall out here. I don't know. Let me
Wall?
go ahead. Okay, well, I think things are there. I'm just going to start the class off here. This is our ENGG 102 class, and our guest speaker tonight is Zobiur Rahman. He's in Edmonton with us tonight, and I really want to thank him for joining us online. It's fun to have people not right in the room, and we're able to speak with them sort of nose to nose. Again, we'd ask you if you could put your cameras on, allow the video, and then Zobiur can see you. I'll monitor the chat line. If you have any questions that you'd like to ask, just type them in, and then I'll sort of interrupt Zobiur and pass them on to him. So thanks for showing up, everybody. Thanks to Zobiur for joining us. And I'll turn it over to you, and I'll stop my video, and that might make a little more space for you.
Just a quick question.
Yeah.
Yeah, go ahead, Joshua.
Should we not, do you want us to just unmute our mics, or would you like us to raise our hand and wait for you to respond?
Yes, so keep it muted.
I think that's the best idea. If you're able to see the hand raised, that would be great.
But I may not be able to, after I start a presentation, I may not be able to. So I don't know, Neil, if you can monitor that. What we can do is this particular presentation, I put together a lot of slides and videos so they can visualize things. You know, it'll be a little different than last couple of years when I was coming up there, right? So they could see me there. But here we will watch videos. But if you have questions, raise hands, and then either Neil will flag it to me that, okay, Joshua has a question, or Ryan has a question. You know, then I'll stop and listen to the question, and we'll answer, and we'll move on. How that sounds, everyone?
That's good.
Raise your hand if it's okay, if you agree. All right. Everybody in, Neil? Everybody that you know?
Well, there's 15 on, and it's pretty close. If there's 3 of us, that puts us at 12, so we're pretty close to the full house. Okay, I can see your PowerPoints over here. Go ahead.
Yeah, you can see now? Okay, okay, wait a minute. I don't see something here that I wanted to see. Okay, here you go. Because I have to, from other screen, I have to move the slides and everything. So everybody can see now? I think there's another Jex. Okay. So again, good evening, everyone. I'd like to thank Keyano College for inviting me again this year. I'm pleased to be here with you all. This is definitely an unusual year for all of us. Yeah, it's gonna, I'm sure 2020 we'll all remember for years to come. So in today's presentation, what we will try to make this presentation is interactive. Like we talked about, that we'll have quite a few slides and videos. So anytime you have a question, you'll raise your hand, or you can even chat box, you can write up your question. You know, if you can't wait until the video is over, then Neil I hope Neil can help me that, okay, this individual has a question, then because I won't be able to see you guys right now and when I'm sharing the screen, because the second screen is I have to move the slides and etc.
Okay, just to interrupt, one student just mentioned he doesn't have a webcam on his recorder, so
That's fine. Yeah.
Blank name. But he can type something on the chat line, and we'll see him then.
Yeah, exactly. Or he can even speak. I don't know if he has a speaker or a microphone that he can speak and ask questions.
I do have a mic.
Great. Yeah. So again, I mean, we're going to try, I know a couple more joined since I spoke, so we will try to make this interactive and fun presentation instead of boring. You know, typically if I just keep talking, it's going to be kind of boring. So in between, you will have questions, and please fire away. And yeah, so Neil will help us guide through this. We're all good, right? Let's do this. So this is your first year of engineering, and I know all of you are excited and anxious to get going and rule the world or discover the world. So I will talk about today a branch of civil engineering, which is called geotechnical engineering. So geotechnical engineering is essential engineering in any type of building projects like bridges, roads, high rises. You're in Fort Max, there are lots of plants around. Every building in the plants, when they build, first thing they do, if they require, is one of the most important parts is the geotechnical engineering. So geotechnical engineering deals with soil mechanics, raw mechanics, investigates subsurface conditions. It deals with slope stability. Rock slides, earthquakes, sinkholes, etc. So this is a very important engineering field. So you will go on to take some engineering in your third and fourth years, and I hope this particular session will help you decide if you want to be a civil engineer. Anyway, so like I said, all the projects will require geotechnical engineering. So what a geotechnical report means. A geotechnical report means something different for each of the parties that are involved in the process. For example, owner or developer, what it means to them. A lot of times the owner engages geotechnical engineering in pre-purchase stage or before he buying the property for a project that he has in mind. For example, he wants to use it, want to buy a property for a mixed-use high-rise building. So now or a 5 or 6 story condo. Now, geotechnical engineers, they come in, perform investigation, and give the owner indication if the site is buildable, or outline some challenges that they may face. A lot of time, owner or developer would hire an architect first to build a project. And that architect in turn hires a geotechnical engineer to understand what the soil condition is. Can I build the foundation that I want in this particular area? Engineers, like especially structural or municipal engineer, require that a geotechnical engineer provide them data for designing their foundation. For example, they want to design footings or piles. So geotechnical investigation tells us what the soil strength is, what depth they can put those foundations. Can the pile be installed in 7 meters, 10 meters? So the engineers, they also sometimes hire a geotechnical engineer to perform those things. Contractors. Now, it is important for contractor to understand what type of cut or fill would be required to balance the site. Do they have to bring in the fill? And what type of fill they will bring in? Where the water table is prior to bidding on a project. Because if they don't know those information, they will be kind of shooting in the dark, and they will be making a lot of mistake when they're building. So a geotechnical report provides them the information that they need to properly bid on a project. Now, municipality, all the new development permit requires a geotechnical report. Always, like Fort McMurray, Calgary, Edmonton, pretty much anywhere in, I work only in North America. I can tell that North America, it requires the geotechnical engineer is part of the package. Now, the geotechnical report tells the municipality where the slope had to be assessed or not, where the setback area is, what type of soil condition we have. Is it very wet? Is it muskeg? What do we have to, it's all addresses. Geotechnical report addresses all those concerns. So geotechnical report overview, typically a client of the geotechnical engineer would send out a request for proposal. Now the geotechnical engineer, typically what they do is they do kind of quickly study what the area is. They use now technology, Google Maps. Sometimes they go to the field to understand, how many holes they're going to need, what depth, how many samples they're going to have to take, where the SPTs have to be taken. So based on those assumptions, they come up with the price. Once that proposal is accepted, then the geotechnical engineer go to work, which is try to organize field work. Now, field work, most important part is the safety. So we want to make sure that the site is clear. There is nothing hazardous, like 3 meters below, 5 meters below the surface. So what they call is in Alberta, in Canada, it's very standard. Alberta has call before you dig. So we call that, and a lot of time we discover there's gas lines, there's pipelines, so we have to be away from those pipelines or gas lines to make sure that we are not creating harm to the rail rig and the people that are operating it. And a lot of time in a site that's already developed, there is electrical lines, on shallow utilities. So in order to locate those, we hire private locators. So they come in, locate those, mark those. So when the geotechnical engineer goes in there, they make sure they avoid those lines. Now, field work, like I said, what we'll analyze, it'll be 5 holes to 10 meters or 6 holes to 9 meters, depending on what we are building there. Sometimes high rises, we need to drill holes to 30 meters into the bedrock or wherever the bedrock is. and then we collect samples. So and that sample is taken to a lab and analyzed. They'll do different tests to come up with the calculations and also report preparation. So those information are used for that purposes. Now there are many different type of drill rigs out there around the globe, to collect this information. Here are the few common drill rigs that we use in North America or in Canada. So it's M13, 150 GTS, CSR 155, etc. So this video, there is a video that will show, this will demonstrate in animation what is the drilling process is, how we collect samples. Hope that you can enjoy this video and hear it. Please let me know if you have any questions after. You can raise your hands and we will try to answer them as we go. Here we go.
The four most common drilling techniques: solid stem augering with the open hole method, hollow stem augering method, the wash boring method, and the casing method. It will also cover the basics of pushed and driven samplers. There are a number of types of drill rigs available. Some of the most common are large truck-mounted rigs, sometimes called highway rigs, off-road track-mounted rigs, and trailer-mounted or portable rigs. Different rigs are suited for different site conditions and different drilling and sampling methods. The large truck-mounted rig is the most versatile and one of the most common drill rigs used. However, it can only be used in situations where it can be driven onto the site. The process of drilling is similar regardless of the type of drill rig used. First, we position the rig over the location where we wish to drill. Then we erect the drilling boom or mast and make sure it's vertical. A drill head mounted on the boom is the mechanism used to perform the drilling and sampling operation. The drill head provides two motions to aid in drilling. A torque can be applied to rotate the bit, and a vertical thrust can be applied to raise and lower drill bits and other equipment. There are many different drilling and sampling techniques we can use to investigate the subsurface conditions. One of the simplest is the open hole method using solid stem continuous flight augers. The flights on a continuous flight auger run the full length of the auger. At the tip of the auger is a cutting bit. The inset photo shows two different diameter solid stem augers with two different types of cutting bits. The auger is rotated and pushed into the ground by the drill head. The bit at the tip of the auger loosens the soil at the bottom of the hole, and the flights carry the cuttings to the ground surface. An engineer or geologist can estimate when new soil layers are encountered by observing the changes in the cuttings as they're brought to the surface. These cuttings can be collected as bulk samples. However, they are low-quality samples because they're completely disturbed by the cutting process and because soil from the upper layers can contaminate soil from the lower layers as the cuttings are carried up the auger flights. When the boring reaches a depth where a higher quality sample is desired, the auger is removed from the hole to make room for the sampling equipment. In this method, the borehole must be able to stand open without support, which is why we call it the open hole method. When we wish to take a sample, we replace the auger bit with a sampling tool or sampler. Nearly all soil samplers consist of some sort of hollow tube which is inserted into the soil to retrieve the sample. There are many different designs of samplers to suit different soil conditions, but the basic process of sampling is similar for most of these samplers. The sample tool is lowered to the bottom of the boring and then pushed into the soil below the bottom of the boring. When the sampler has reached its full depth, the rods are twisted to shear off the bottom of the sampler, and the sampler containing the soil sample is retrieved from the boring. The sample is then stored for later analysis and testing. The sampling tool is replaced with the auger, and the auger lowered back down the hole. Augering continues until we reach a new layer where we wish to take another sample. The auger is then retracted from the hole and replaced by the sampling tool, and another sample is taken using the same process. When the soil is very stiff or dense, it's not possible to use a push-type sampler. In these circumstances, we use a heavy-walled sampler that can be driven into the soil using a drop hammer. The process is similar to retrieving a push-type sampler, but uses different equipment and a different sampler. The open hole method only works if the soil is stiff enough and strong enough to remain open after the augers are removed. While it is often possible to use the open hole method, many times the soil is not able to maintain an open hole for sampling. If the soil is soft, it may squeeze into the boring when the augers are removed. This often happens in a soft clay layer. If the soil is a clean sand with little or no cohesion, the soil at the sides of the hole may cave or fall into the boring. This is particularly a problem when drilling in sands below the water table. When squeezing or caving conditions occur, we must use a different drilling method that will support the borehole during the sampling process. One method that can be used in caving or squeezing soil conditions is the hollow stem auger method. In this method, we use a continuous flight auger as in the open hole method, but in this case, the auger stem is hollow. The bit in the center of the auger is retractable and can be removed through the hollow stem. The inset photo shows a hollow stem auger and its retractable center bit. For illustration purposes, the center bit has been removed and is shown next to the hollow stem auger. During drilling, the center bit is inserted inside the hollow stem. The augering process proceeds in the same fashion as with the open hole method. When we reach a depth at which we wish to take a sample, we stop augering, detach the center bit from the auger, and remove it.
All right. Thank you, everyone. Anybody, any questions so far? Neil, do you see any notes?
I don't see any questions typed up here.
Okay.
Go ahead.
So we'll continue. So in this previous video, you saw the animation of the drilling process. So this one would be a short video from a EIT. One EIT went to drill on a site where a road design will take place. So please watch this video.
My name is Pearson Holt. I work with Building and Earth Sciences as a field engineer. We're out here in Fountain Heights drilling for road improvements, new traffic lights, new light poles, and a raised median in the middle. So Lee and Terry behind me are currently sampling soil. We sample every couple feet, and what is going on right now, that's a hammer, it's a weight, it's a 140-pound weight, and we know how far it drops, so we can reference that to how hard or soft the soil is, give them, the structural guys, a report, and that'll base their foundation design off our report. So this rig is a CME 75, and what we have are hollow stem augers. The hollow stem, they're hollow in the middle, so we drill down to the depth we desire, and then we put a rod in it, a spoon, it's called a split spoon, and we put the hammer on top of it and count how many blows per 6 inches, and we come up with the end number from that. For roadways, it's different. You can get away with softer soils depending on the traffic. Maybe in a parking lot, it can be softer. Depending on how much weight's going on these light poles and how big they are, we usually stop somewhere 8 to 12 is pretty good soils for these. And that's kind of how it always depends. Every area you drill is a little different, even if you're in the same formation. It's not boring, but it's boring. Every day's an adventure at Building and Earth Sciences.
Neil, can you hear the sound of the video and everything is good?
I can hear the sound.
Okay. So everybody, yeah, so I hope, we had over the period of COVID, I had to learn how how to do this in Zoom, so it's kind of interesting. So anyway, so once the field investigation is completed,
Zolby, you're,
yes.
sorry, I just sent a question to you. I was a little concerned raising the mast of that rig under the power lines. Any chance of arcing so close, or would they have turned those power lines off?
Okay, but it's very good question, Neil. So there is a strict guideline. So in this case, these power lines were not active. This is a new subdivision that they were drilling on, but when an active power line going, we have to be 30 meters away from that to drill. Very good question, Neil. So here we go. So once that field investigation is completed, so we collect samples, and those samples are taken to the lab for different type of tests. Like a moisture test, that's very common. Typically geotechnical engineers do air moisture test for all the sample in all the depths that are collected. And then when the sample comes to the lab, geotechnical engineer who's going to write the report, sometimes they're in the field or sometimes they're not. They look at that sample, and based on their observation, they decide, okay, we're going to do 3 out-of-work limits or 4 out-of-work limits or 20 out-of-work limits. And at these different depths, at 2 meters, 3 meter, 5 meter, they write a lab testing notes to the lab technician. Then they perform those out-of-work limit tests. Now, hydrometer is another test that's commonly used for designing purposes. So again, geotechnical engineer, they don't do hydrometer for all the samples. They pick few to understand the what type of soil there is. Grain size analysis, same. They pick a few that perform the grain size analysis test. And California bearing ratio test is. Now, once a geotechnical report is completed, the job of a geotechnical engineer is not done. Geotechnical engineers gets involved in throughout the construction phase, from the ground all the way to the completion. They make sure that the specification that is specified in the geotechnical report or different specification are followed properly to ensure that the project is safe and it has no potential to be failing. Anyway, any questions so far? I don't actually see.
They're very silent. They're trying not to interrupt you.
Okay. No, I mean, yeah.
I have to turn my video off when you're talking, because even though I got the sound on the earphones, it interrupts. Keeps putting my picture back on, so that's why I'm going in and out. Just a couple of comments. Students, you may not appreciate the sort of the importance of some of those items on Zolbier's list. The two that struck my fancy were the ones about depth of frost penetration. And usually it's something that people worry about because they don't want pipes and water lines freezing, so you want to be below the frost. But for example, at the oil sands open pit mines, in the winter, they drive the frost down. They keep bulling away any material such as snow or ice that covers the roads, because they want to get the frost as deep as possible so that it's solid and so on for the heavy haulers to get around. And then the other point was about the radon, and that of course comes from decomposition of radioactive minerals in rocks. And I guess, Zoba, you've had more experience on this. In most of Alberta, where we have the sedimentary rocks, there's not a lot of radioactive minerals, but anywhere on the shield or in areas where you have igneous rocks, you do have radon quite in quantities in some of those. And so people will build houses in those areas, and then the radon will accumulate in the basements, I guess, in particular. Is that a fair statement?
Yeah, thank you, Neil, because your geological background obviously come to play here. But so nowadays, what like, for example, we're building for recently we're building 5-story, 6-story condos. What we do is we use radon mitigated rock as a backfill material, and then we put a vapor barrier on top. So that's very common practice nowadays. Anyway.
Okay, thanks. Yep, happy to hear. Yep.
Yeah, thank you, Neil. Thank you for your comments. So,
sorry, there's one question.
yes, sir.
The question is that the same thing as permafrost? I don't think so. I think we're talking
No,
about...
permafrost is mainly that permafrost engineering deals with the north, further north, not Fort McMurray, like Yellowknife, etc. So that's where the permafrost come to play. You know, this is just completely different geotechnical field. You know, it deals with the material that's always frozen. So no, that frost is different. Like Neil talked about, like we have to know where the frost level is. We want to put our underground utilities below that. For example, Fort McMurray, you would see most of the water lines are below 3 meters, so that it doesn't freeze even in -50 or -55 degree temperatures. So it doesn't feel the impact, you know, frost and heave actions. So anyway, moving on, foundation. Good question though, thank you. Foundation is the most important for any structure. So there are many types of foundation that are used for a building, like high-rise, condo, commercial building, and mine sites. If the foundation are not installed properly, the structure have high probability to fail. Over the next few videos, we'll show you how different type of pile foundation are installed. So I think it's very interesting for me. I hope you guys will also enjoy it. Like, look at this. This is me actually. You know, this is a monopile foundation that they built. You can see the diameter of this monopile is about over 10 feet, and it had to be installed for a tower project. So very interesting. This. So next video we're gonna show it's gonna talk about continuous flight auger piling. Now when the soil condition is very poor and the hole has potential to collapse, these methods are used because this is a very fast method and you know, very effective.
Continuous flight auger piling is a fast and economical piling method, ideally suited to wet or granular ground conditions, which otherwise would require the use of temporary casings to support the ground. Pile depths of up to 32 meters depth can be achieved using powerful crawler-mounted drill rigs. A CFA pile is constructed by rotating a full-length auger into the ground to the required depth. Auger diameters from 450 millimeters to 1200 millimeters are common. The auger has a hollow stem which is connected by a flexible hose to a concrete pump. The hose and stem are charged with concrete before drilling commences. Once the auger reaches the required depth, concrete pressure dislodges a temporary cap at the base of the hollow stem, and concrete is pumped under pressure into the ground while the auger is withdrawn, carrying the excavated soil upwards. Different designs of auger cleaner require the auger to either be stationary during extraction or to be slowly rotated in the same direction as used when drilling. Soil is flighted up the auger and is removed by an auger cleaner just above the ground surface. Once the tip of the auger returns to ground level, concrete pumping ceases. The accumulated soil is then cleared away from the pile head. Then a prefabricated reinforcement cage is plunged into the pile while the concrete remains fluid. Special attention to the concrete mix design is required to maintain its workability and to ensure that the reinforcement cage can be inserted to the required depth. The pile concrete is allowed to set before nearby piles are constructed. Piling contractors. Think safe, work safe, home safe.
Hopefully you enjoyed that video. So the next one I'm going to show you. It was a lot of fun. I mean, I did steel piles in Fort McMurray in one of the shell sites. But this particular one, you know, it's going to talk about how the soil is very weak, and then the strong strata is way below. So how do you connect from the surface to all the way down to the bedrock or shell, limestone, etc. So that's where the piles are founded. So here's the video. Watch.
If you're planning a lakefront build, I'm going to show you how to do a steel pile foundation. Our company is just starting this beautiful new home here on Lake Austin. We're working with Shiflett Group Architects, and I want to talk to you about the foundation that we're doing for this very special lakefront house. As you can see, we've got a beautiful flat lot here, and it drops onto Lake Austin beyond us. Lake Austin is a man-made constant level lake. We're right near downtown Austin, and the beauty of that is we don't have to worry about the rising and falling water levels. However, the downside of this property is we've got a water table that's just a few feet below my feet right now. If I were to dig a hole right next to me here, about 4 feet deep, it would start filling up with water. And the way that we deal with that on this particular lot is we're going to be using steel piles. Anytime you build a foundation, the first step is always going to be to get a geotechnical engineer out to do a core sample for you. And when he came and cored this lot, he drilled all the way down until we hit rock, just a little over 50 feet deep. What we found was good soil the first couple feet, and then very soupy soil from that water table all the way down until we got rock. So steel piles were the recommendation from the structural engineer here. So let me talk about how this works. When we get finished, this is going to look like a very typical slab on grade foundation, but the steel piles are really going to be doing the heavy lifting of supporting this foundation. Here's how we do those. Those steel piles are put in by a pile contractor. The first step on installing these steel piles is to drill about a 10-foot deep hole, and that's going to give us a starter for these columns. Now these steel piles, they come in about 30-foot lengths. They're 3/8 inch wall steel, and they're about 8 inches in diameter. And before we start driving these, we're going to weld a cap. We don't want to have that column fill up with either water or mud. We want to keep that column free so we can fill it later with both rebar and concrete. So the first step after we drill that then is we're going to drop that first pipe in, and you'll notice when the forklift comes, that first 30 feet goes down like nothing. All we got to do is just press it down with the forklift. Now I mentioned rock was 50 feet in depth, and these columns come in 30 feet. So once we're just a few feet out of the ground in that first column, we're going to have to bring another column and weld these two sections of column together, and then we can continue pushing that. Once we get to about the last 5 feet or so before we hit rock, the forklift can't do it any further, and that's where we need to bring in the pile driver. In this case, we're using a crane supported pile driver, which is going to drive that steel column all the way down until it hits refusal. In this case, we hit rock between about 55 and 60 feet in depth. And so now these steel piles, once they hit rock and hit refusal, each one of them can hold 300,000 pounds of bearing capacity. Very, very impressive. The engineer designs these in a very specific grid pattern so that our point loads from the house on onto the slab are distributed to these piles. And now in effect, our house is floating above all that soupy mess below us. Now that the steel piles are in place for both the house and the landscaping, we're going to bring in our concrete crew. They're going to be forming up the house slab, and we're going to integrate the house's rebar into these steel piles. We'll come back in a couple weeks and we'll show you the progress. Okay, we're back. It's been a couple weeks, and as you can see, the concrete guys have done a fantastic job. We're just a few days away from pouring this slab, but let me show you now that we're set how we've integrated this concrete slab in with those steel piles that we drove. So remember last time we drove those piles all the way down to bedrock, and you'll notice those piles are at the bottom of our beams. If you're not familiar with a reinforced concrete slab, you typically think of your slab thickness as just a few inches. In fact, this will be a 5-inch thick slab, but all the strength from the slab comes from the beams. That's that grid pattern you're seeing that's deeper all the way through this foundation. Inside those beams, we've got a rebar layer that's going to integrate into the concrete and stiffen this slab and give it its strength. And at the bottom of the beams, that's where that steel pile is going to be. Before we got to this point, we filled those steel piles with concrete, and then we've got rebar sticking out. And that rebar is going to integrate into our slab rebar, so that now we've got this grid pattern of beams. At the bottom of those are piles, and in fact, the entire concrete slab is going to sit on those piles. Each one of those piles can bear 280,000 pounds of bearing. So we've got several million pounds of bearing capacity on that steel now that we're all set. This is a really impressive foundation. If you're not familiar with the yellow plastic, that's our vapor barrier. We're using 15 mil Stego wrap here. That's going to keep any moisture that's in the soil from getting into our concrete. And now when we pour this next week, we'll cover it for a few days, and then we'll be ready to move on. You know, you want to spend the time and the money to do your foundation right, because no matter what you do on top, if your foundation moves, you're going to have big problems with your house. This is the best way to do it if you've got really bad soil. I'd highly recommend you talk to your engineer, your builder, or your architect about whether steel piles might be an option for your property. Otherwise, we'll see you next time on The Build Show.
All right, guys. I typically I do it in person, this presentation, so I could see the face reactions, and it's probably seems like overwhelming to you right now, but let me tell you, it's fun.
That's on your calibration.
Anyway, that's the video. So anybody have any questions so far?
So I don't know. Are they not supposed to? I know there's no like equipment or nothing, but are they not supposed to be wearing hard hats?
Sorry, I didn't understand the question.
That's it. I know that I understand that there's no equipment around, like machines or nothing, but then are they not supposed to be wearing hard hats all the time, regardless of the situation? I don't know.
Yeah, I mean, I agree, but yeah, good observation. Somehow this video, they just wanted to demonstrate for students or audience, so they were not. Yeah, you're right though. You always should be wearing your PPE while you're in the field, in the construction sites, and doing tests. But in this case, they were kind of, you could see in the background, the construction site was kind of far from there, but you're right. Always wear PPE. Good question. Good observation.
I have a question.
Yes.
So to become a geotechnical engineer, do you have to first become a civil engineer and then gain experience while doing civil engineering, or take some extra courses in university?
Very good question. So in order, like myself, I just became a civil engineer. Then when I went to work, I just start working in the geotechnical field and working under geotechnical engineers. Now you can better yourself by even taking some advanced courses, but it's not required all the time. You can just learn on the job, like I learned, like everybody in this class, you guys won't practice as an engineer as soon as you graduate. You're going to be working under a senior engineer and learn the ropes. That's just standard And then, so to answer your question, no, you become a civil engineer, you get your degree, but as you are taking a degree, I would suggest, do the co-op. Like all the civil engineering companies, a lot of companies, they hire civil engineering students to do the tests, some of the tests that I was showing you in the videos, and I'm going to show you a few more. These are just very basic things that we do in the construction sites. And you learn as you go, and then you become an expert, and you show, well, with the years of learning, this is how you grasp knowledge, being around construction, learning how to solve problems, working with engineers, asking questions like this. Yeah, good question. Any other questions?
Can I make a comment?
Neil,
That
please,
the
please.
the last video is really interesting, and I'm not sure that students, unless they've had some exposure to soils and construction, don't appreciate how important those compaction tests are. And the simple idea is that the soil, there's a certain moisture content, sort of the optimum moisture content, where you can compress a soil. And so that's what you want to do. You want to compress the soil, squeeze it down as much as you can so that it will never settle anymore. Because once you put a highway or a tailings dike or a large building on top of that, if the soil compresses because of the weight of the overlying load, well, then you're going to have settlement, and you don't want you don't want settlement on any of those structures. So it looks like a kind of routine type of testing, but the implications of not having the optimum moisture content in your soil before you put all that heavy load on top of it, can be staggering. I mean, you can have structural collapse, you can have cracks in the building, you can have, even failures of highways or dikes or so on. Maybe I'm simplifying it too much, but it really is important, and you have to be very rigorous and professional. Even if, say, you're hired for summer work to do that testing, you want to make sure that the results are absolutely accurate. I think, Zobair, there's a bit of tolerance, right? You can be maybe within 5% or 3% perhaps of
Yeah, typically the moisture
content.
Yeah, typically it talks about, sometimes we say 0 to 2%, +2, or we say ±2%, depending on what the structure is, depending on what the soil condition is. So there is a tolerance, and an opportunity, Neil, because I used to hire a bunch of students from Keyano College every year when I was with AMAC, and they did a fantastic job over the year. Like Pam McGraw came out of there. I think she's still working there. I remember she graduated from Keyano in the environmental program, but she learned very well. But again, these results, yeah, you go to the field, you learn how to do it, but it's been reviewed by an engineer to make sure that there is another layer of protection there to make sure that that there is no mistakes made, or
Right.
we can catch the mistakes prior to going to the clients. Sorry, go ahead.
Quick question, sir.
Yes.
Neil was talking about settlements. Isn't that going to happen all the time, regardless of what happens? Like, let's think about when it's snowing and it's frozen, and then the summer hits, and then you start doing the project or whatever, and then eventually the water underneath the frozen ground, because the ground somehow somewhere down there it's still frozen.
Very good
It
point.
could happen.
Very good point.
Okay,
So,
yeah.
so the Neil was saying was what was trying to say is like this soil is compacted so that typically the frost hits the water, and water, what happens? Well, water becomes ice, it expands. So it's called frost and heave action. So you want to mitigate that. You don't want that under your, for example, under your building or under the road. But still, we have very high plastic clays in Fort Mac and Edmonton. So you can see under the asphalt layer, always the asphalt has some failures. It happens due to our extreme nature of weather, but we try to mitigate it, keep the subgrade very strong so the subgrade doesn't fail. So through this compaction and other methods. So compaction is one of them. Good questions. And any other questions? Very good questions coming out.
Just one more comment. Often the when the testing is done and they find, for example, that the soil is too dry, they have to add water or moisture to get the soil to that optimum content. I used to think, when they were doing the twinning of the highway, there was lots of exposures. Everybody could see the construction going on, and I always thought they were. Before I started working up here, that the reason they'd have water trucks out there was just to keep the dust down on these large areas. But that wasn't the reason. The reason was they were adding water to get the moisture content to a more optimum level. It wasn't dust control at all.
Yeah.
That's all. Yeah.
Yeah, good point, Neil. A lot of times it is done for dust control. Other times, if the moisture is very low, it's dry, it doesn't compact very well. We're not gonna achieve 100% or 98% compaction that we're looking for. So we need to, like gravel, for example, it dries up and you keep rolling it, but it doesn't get the compaction. So what do? You scarify it, add some moisture to it, place it back and compact it, and you'll see that you get the right compaction that you want and at the closer to optimum. But yeah, like a lot of times in summer heat, the material becomes very dry. Yeah, sorry.
Sometimes when it's like that and you want to, like, let's say you want to put on, like, you're digging a hole and then it's wet down there, but you still have to finish the project by a certain date. Don't you take like a concrete and then you sprinkle it and then it kind of like settles everything?
Good point. So what do you call? We call it cement stabilization. Yes, it's done in like we have a very short window of construction in Alberta. So a lot of time we don't have the luxury for the material to scarify, dry, and place it back. So what we do is we do different techniques. One of the technique is that you saw, which is called cement stabilization. It is an expensive process, but a lot of clients tend to do that to expedite the timing of the construction. The other times we may place geotextile. We put low strength concrete, etc. We do other things. It's just different techniques are used.
Okay, any more questions? I guess if not, on behalf of the students, I'd like to thank you, Zobair, for, first of all, for arranging to be with us, and secondly, for presenting so much interesting material. You can see Zobair is a very experienced and proficient person using Zoom, and hope you appreciate that. And I think we can all learn from him some of those techniques as well. Last question for me is, do you get up to Fort McMurray very often? If you do, drop in and say hello.
Absolutely. I mean, I was looking forward to this session. As you know, I mean, I always enjoy seeing this first year students. I mean, I find, and I learned a lot, from interaction over the last few years. I came I had a lot of today. It was not. I mean, this is how the reality is. But over there, we were more interactive, and we could be because we're in our face. We're face to face, and a lot of interesting comments and questions came up. But I try to make this presentation, just more video, just so you can visualize a lot of things. And in the future, I will do that, but I will be interacting with you in face to face. Hopefully, in the future, I mean, I will be coming to Fort Mac for sure. I still kept a home there because Fort McMurray is like my second home. I learned a lot from that city. It's a beautiful city, so it's dear to my heart.
Well, that sounds great.
Thank you.
So could everybody turn your mics on maybe, and
Thank you, sir.
Thank you, everyone.
Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank
I
you
have
so
a
much.
question.
It's always a pleasure working with Neil and his students. And I wish you guys all the best. Again, reach out to me if you have any questions, even just how to go about engineering, because engineering, it's beautiful. It's hands-on, and it's easy for me. If I can do it, any of you can do it. So, and you don't have to learn everything in one day. You'll learn as you work in this field. You'll gain more and more experiences. Thank you all. Wish you all the best. And thank you, Neil. Thank you, Keyano College.
Oh, okay, guys, if you could disconnect and end, I'd like to stay on, talk to Zobair just for a couple of minutes after you go.
Have a good night.
Good night.
Good night.
Good night, sir. Good night, sir. Thank you.
Thank you. Good night.
Good night.
Good night. Thank you.
Well, looks like we're alone. Three participants, and two of them are me, and
me.
one is you. I'm going to turn the monitor off here,
Okay.
if that's okay.
Yeah.
So, yeah, I've learned to have them pretend I'm a student and watching, because otherwise things come up on the screen that I'm not aware of sometimes. So thanks again. I won't take a lot more of your time. I really appreciate your time and effort. And, I was kind of watching the attendance, and nobody left. Everybody stayed on the whole time, which is, you should take as a real compliment, because, in my lectures, often I see people have left or disappeared sometimes. I think they're very interested in, the idea of this course is to expose them to the different types of engineering, and, having somebody who's lived here and worked here and run projects up here is very, very helpful.